Welcome guys, how it's going? In today's question we have a tree with us, not this one, a binary tree. In that and a binary search tree. In this binary search tree what we need to do is we need to implement three functions. The first is it's a constructor, second is a .next function, and the last one is hasNext function. So what do they do? It's explained here. The constructor should initiate the iterator that we are going to use. Let's call it a pointer or a reference or anything which will have some thing. Second, what the hasNext function must do is it must return true if any other element is present that can be traversed in the tree. If any other element that can be traversed is present in the tree. And what the next function does is it returns the next element. So how are we going to iterate this tree? We are going to iterate it in order traversal. So in if you know the property of a binary search tree, you know that its in order traversal gives you a sorted list. So now what we want to do is we first need our reference to be here at 3. Then if someone like uses .next function, then it must return 3 and then it should go to 7. Or if someone if we are still at 3 and if someone uses hasNext function, then it should check if 7 exists or not, and then it should return true or false. Now how are we going to do this? We have actually two ways to do it. The first way is to already sort, or I mean already iterate through this binary tree and save it to another data structures which can be iterated in O of one time. So what we can do is we can convert these values into an array, and then we can implement the hasNext function or next function into it. First I'll tell you how to do it with an array, then I'll tell you about a more optimized approach in this. So with an array I have commented things out. I'll be uncommenting them and I'll be commenting things which are not required. Okay, so here first we need to declare an array, simple. Then we need to declare a index. I have called it a iterator, we can call it an index. Then next what we want to do is we need to in order traverse the array, we need to in order traverse the tree, and then also initiate the iterator. Why is it at -1 right now? Because whenever we are going to return the value, we'll be first updating the iterator, and then only we'll be returning the values. Yeah, I didn't know that can happen. Yeah. And then again what we have here is hasNext function or not, and this function. We need this function, and right now we don't need this function. So I've implemented both the methods because I wanted to try both the methods. The first method is a brute force method, which instantly came to my mind. It's like an intuitive method, but the second method was I had to do some research. I have to take some hints, and then only I came up with the second method and I implemented it. So firstly, for the array, what we do is we traverse the tree in an order fashion, and what we do is each time we are traversing we add the root node to the to our record, and then if someone asks for our next record, what we do is we increase the value of iterator. Right now at first it's -1, but each time it increases, and then we return the value at that iterator. And moreover at hasNext, what we do is we check if the iterator is at the last index or not. If it is at the last index, return false, otherwise always return true. Quite easy to understand, nothing to do here, and easy to implement. The second approach, which requires O of h space and also O of 1 a constant time, is somewhat different because there we'll be using a stack. Like, see, it's iterating a binary tree. It's quite clear that we'll need to use a stack either recursively or manually somewhere. So now we are using a stack. In that stack, what we are going to do is is, let's understand with this example, we are at the node right now. Now let's create a stack here. I can't draw on this, but imagine there's a stack there, and what we are going to insert on that stack is 3 7, and then we'll insert 3. So now each time you want to remove an element, so each time dot next has been used with that stack, what you do is you pop that element, but you also check if it has a right if it has a right child or not. In this case it does not, in this case it doesn't, in this case it does, in this case it does. So let's take an example. I have pushed 7, I pushed 3, I have popped 3, 3 is printed again. I pop 7. Now before popping 7, what I need to do is I need to check if 15 exists or not. Of course it exists. So what I want to do now is I want to add 15. I want to remove 7, clear. I want to add 15 9 to the list. So this is how we are going to do this here. And in the constructor we'll assign memory to this, and then we'll call the function which is the leftmost node, because we are calling the leftmost node of that parent node. Okay, so in the leftmost node we are just checking if node is not equal to null, then push the node, and then make this node equal to its left counterpart, left child. Quite simple. Again, yeah, what we want to do in next function is we are popping that node, we pop that node from that, and we return the value, but in between we need to check few things. If its right sibling if its right child exists, then what we need to do is we need to grab the leftmost node for that right child. So for example, if 15 exists, we need to grab 9, and hence again that we will have 20. How do we know that? Because when 9 is popped, then 15 comes in, and in 15 we check if it has a right child or not. It does, and we grab the leftmost child for this node, and it itself is the leftmost. It does not have any children, so it is the left child. And it's quite simple, quite easy to understand. It takes O of h space, which is the height of the tree, each time when I insert any element into that stack, and it is O of 1 function. And let's check if it works or not. I hope, yeah, it does work. And that was the video, guys. It's quite simple, and I did both the methods. This one took less memory and the previous one took a little more memory. So see you tomorrow. Bye bye.